We have our last graph. Here we go. So we're going to plot this out. Let's see how we do. So we got time of 0 through 4 again. So I'm going to write out my 0 through 4 over here. 0, 1, 2, 3, and 4 seconds. Position at time of 0 seconds is 0 meters. So far, so good. Time of 1 second is 1 meter. Yeah, that's easy. 2 seconds. At 2 seconds, I would assume that if we're looking at the front of all these cars, well, the front of this car is past 2. I'm going to guess that's about 2.5. All right, 3 seconds is 5 meters. And 4 seconds is going to be 10 meters. So we plot that out. My 0, 0 is down here again, so I have 0 seconds, 0 meters. Okay, 1 second, 1 meter. All right, 2 seconds, 2.5 meters, which is about there. 3 seconds is going to be 5 meters. And 4 seconds is going to be 10 meters. So first it's asking us, would a line of best fit work for this? And let's think about it. If I try to get this arrow or get these rulers going, there's nowhere I can go that's going to get it lined up with more than just 2 lines. Okay, so I would say the answer is no. We can't do a line of best fit. Okay, so straight lines would not be the best way to graph this. Okay, so I'm going to say no, but and you can talk about it, but the idea is that a line of best fit would not match up more than 2 points anywhere. And we can kind of see it looks like it's kind of curving up, right? I'm just going to do a random curve, but it looks more like it's curving up like that. So a line is not the best answer for graphing that. All right, so how does the motion in car E, how's that different from all the other cars? Okay, so looking at this motion, we see spacing that gets further and further apart from here. Okay? So what that would mean is that this car is going to be speeding up. It's covering greater distances between the time spaces. Okay, so the motion is different because this car is speeding up compared to the other cars, A through D. They were all going at constant velocity. They're all going with the same speed the whole time. Okay? So that is probably, the speeding up is probably why we can't get that straight line. Okay, so here we go. Now let's summarize the meaning of the following over here. All right, the value of the slope. What I would say the value of the slope represents is velocity. Okay, so velocity or speed. Okay, for some would be speed, except speed doesn't really care about direction. You can't have a negative speed, okay? But really, how fast you're going would be velocity. All right, the y-intercept, that would be your starting point of the car. All right, starting point could also be called initial position. All right, so initial position. And I'm going shorthand with just POSN, but position you can spell out. The sign, the positive or negative of the slope. Well, what we were figuring out from the other cars is that if we have a negative slope, it meant it was going the opposite direction. So the sign and positive, negative in physics class will just mean direction. Okay? Straight line, what we figured out with those straight line graphs is that if we have a straight line, and we have some over here, here's some straight lines over there, right? That meant it was going at constant velocity. So straight lines will mean constant velocities. Okay? And finally, a curved line. What we just found out from a curved line is that means it's an increasing velocity, or an increasing, or a positive acceleration. So it means it's accelerating. Okay, there you go.